Okay, let's get started. Welcome everybody at a new Bytes of Innovation webinar. Bytes of Innovation is a webinar that is powered by Segmed, which is a company that provides medical imaging data for research purposes. At Bytes of Innovation, we invite key opinion leaders to talk about the future of healthcare. It's co-moderated by Dr. Aline Lutz, who is the Vice President of Clinical Insights and Real-World Evidence at Segmed, and by myself, I'm Martin Willemink, co-founder and Chief Scientific Officer at Segmed. During this webinar, make sure to put your questions in the chat or the Q&A box so that we can discuss them later on. Like I said, we invite key opinion leaders at this webinar. Next week, we will have Dr. Tim Stick. He is a professor at University of Wisconsin Madison and also co-founder and CEO at RadUnity. So he will talk about all the great stuff that they are doing, actually in collaboration with Segmed. But today, I'm proud to announce that we have Dr. Pranav Rajpurkar amongst us. Pranav is an associate professor of biomedical informatics at Harvard Medical School, and he's also co-founder of A2Z Radiology AI. His research at Harvard focuses on developing AI systems that match physician-level expertise through multimodal clinical data interpretation. At his lab, he develops frameworks for evaluating and advancing medical AI in clinical language models and medical imaging. He's published over 130 peer-reviewed papers with more than 39,000 citations. And I can tell you that's a lot because I actually have published about the same number of papers, a little less, but definitely not 39,000 citations. So great work, Pranav. He also has educated over 84,000 students through his AI in medicine courses at Harvard and Coursera. And he also has a lot of accolades. Amongst others, he's named among MIT Tech Reviews Innovators Under 35, Forbes 30 Under 30 in Science, and Nature Medicine's Early Career Researchers to Watch. He received his bachelor's, master's, and PhD from Stanford. So really great to have you here, Pranav. And what excites me the most is actually the topic that we're going to talk about, because recently Dr. Rajpurkar published a paper together with Dr. Eric Topol, where they challenge one of medicine's biggest assumptions, and that is that pairing AI with physician expertise that may not always lead to to better outcomes, or we have to do it in a different way, and we'll talk more about that. So first of all, welcome, Pranav. Great to have you here.
Thank you for having me, Martin. Looking forward to our discussion together.
Awesome. Yeah, I would like to open with a question about what actually inspired you to come up with this shift in the perspective of rethinking the partnership between AI and clinicians.
I think when there was a clear set of signals that were telling us that we were achieving human level performance on medical tasks and specifically on medical imaging tasks, that's when I got excited about the collaboration component. And I'm just going to zoom back to 2018. In 2018, my colleagues and I were working on the interpretation of NEMRs with AI. And the idea was for ACL tears, MCL tears, and other abnormalities, how well would models be able to perform? And so we had this AI model, and we did a head-to-head comparison with individual radiologists. And there were a set of subspecialty radiologists who set the ground truth. And we made a statement to the equivalence of we are as good as general radiologists on these particular tears and abnormalities. And now back in 2018, this was very impressive because this was the first demonstration of deep learning being able to perform equivalently to radiologists on a 3D medical image interpretation task. But we wanted to go one step beyond, which was to ask the question, surely if I gave a human level AI output to a human physician, and in this case, the radiologist, that it would produce improvements. And I remember at the time, the way we did this experiment was we had all of the probability outputs in an Excel spreadsheet, which you kept open on one monitor, and on the other monitor was the case itself. And what we found was that on average, there was an increase in the specificity of the radiologists on ACL tears, no change in sensitivity, and overall seemed relatively, reasonable and positive that you increase one of the metrics, but don't hurt the other, which was in this case, specificity went up, sensitivity did not. But what I was interested in was to say, what would be the optimal outcome? The optimal outcome would be that the sensitivity and specificity of the human, as a result of using the AI, both go up. Sort of, your curve shifts up rather than you being on another part of that curve. And just a year later, we were working on a problem where we had a very similar setup, but this time we had a multimodal input. So not only was there a medical image, but there was also associated clinical history. So there were available labs, there was available indications, available vitals. And so we had this information addition. And this was my first experience with an AI model getting to superhuman levels of performance. And we had a clear, performance analysis. And I remember looking at that, and all physicians were much, much below the performance of the model. And the first thing I thought, there must be something wrong in the code. There's no way that this can be possible. And what we found was that if we had only given the model the image itself without the available context, it performed about the same as people. So the difference was actually in the ability to incorporate this multimodal data that made it so incredibly good that we would think of it as superhuman. But the thing that was even more surprising was that we could then give this model output to a physician, and they would override it in the negative way. In that the best case scenario for them, or the easiest scenario for them, would have been just accept the AI output as is, and they would have scored something like 80% in performance. And when they overrode it, they got from 80 to 70 or 65% in performance. Now, this was very complex cases, so it's not representative of a typical distribution, but still goes to say that there is something broken in this collaboration. Now, this was 2020, mind you, and at the time, if you remember, there was very much this idea that was being floated around that the future of medicine was a human physician with AI was always going to be better than a human physician without the AI. Yes, that's fine. That's supported by the data, is that the human physician without the AI is, worse than the human physician with the AI in this study. But what no one was able to openly talk about at that point is raise the question, okay, but is the AI alone better than the human using the AI? And there was very much the sense that if you said that out in the community, that it was the wrong signal to be sending a whole community. And certainly, I think being in that contrarian position means that you have to be scientifically very well guided in terms of how that argument is actually made, because it's certainly not the right argument to be made in many ways from a psychological safety standpoint. And I think the other thing that happened was there were a lot of people who did not understand medicine who were saying that thing, is that AI will get rid of all the doctors and we won't need doctors after this. And of course, completely unscientific basis for that. And so it was at the time that it was clear that there was more to the story. And, I won't do a monologue for how the rest of the next 5 years went, but you asked me for how I got started thinking about this. And this was sort of the moments which got me seriously thinking, and some of my colleagues as well, seriously thinking about this collaboration and its effectiveness.
That's super interesting. Let's zoom in a bit in this physician AI interaction. So in one of your articles, you describe automation bias and automation neglect. Can you explain to us a bit how these two are different and how they manifest, especially in radiology practice?
So let's say you have a AI output, and the AI output says that this image is likely to have a disease. You have your own worldview on that image. So you say, I have, some idea of my own confidence, and I'm going to weigh my own information, my own confidence, versus how much belief I have in the AI. Okay, so for example, if I'm playing chess and I think I know a good move and the AI tells me that this move is optimal, I will put 100% of my weight on the AI because it's so much better than me at chess. It's so much better than any human at chess. But in many other scenarios, I would think that the AI was sort of, didn't quite have all the information, so I would weight myself more. Automation bias is the following phenomenon. It says that I trust the AI more than I should, and I trust myself less than I should. Automation neglect says that I trust myself more than I should, and I trust the AI less than I should. So there's an optimal weight. And if you go on the right of that optimal weight, that's automation bias. If you go on the left of that, it's automation neglect. So just, anecdote to share about that is this was a study that came out of a collaboration with some economists at MIT. And this was actually a study that took us 2 years to do. We started in 2020, and we wrote this paper in 2023, basically. And it was to date, I think, one of the largest scale experiments with 237 radiologists looking at the effect of AI assistance. And we basically showed that the phenomenon most people were considering as the biggest risk, automation bias, was not actually the case in our data. It was automation neglect that was the driver of poor human-AI collaboration.
So do you think these both automation bias and automation neglect, which seems to be predominant, do you think these are the main reasons for traditional AI assistance setups to fail, improving diagnostic accuracy, or do you think are other things as well, such as maybe models are not good enough, or physicians are still in learning curve? What do you think are the main reasons for that?
Yeah. So in that particular study, we attributed a lot of the failure of the collaboration to automation neglect. We also had other explanations like own information bias as the ways of being able to empirically show what leads to the collaboration failing. But let me sort of talk about it more in human language and less in mathematical terminology. I think what is very clear with this generation of AI is that more than anything, the movement from month to month, quarter to quarter, is such that we're thinking about AI and trusting AI very, very differently because the capabilities just look so different. For example, the amount of things I would trust GPT 3.5 back in November 2022 to come up with on its own, and the amount of things that I rely on Claude, Sonnet 4.5 to be able to get right is night and day. The systems of today, I trust a whole lot more to solve a lot of the complex problems than I did back in the day. And that just means that whatever we learn about the nature of communicating with Claude Sonnet 4.5 is going to be very different than what we learn about interaction with 3.5. And there's no reason why we shouldn't be extrapolating out in the future, is that the outcome of the interaction is going to look very different. So what I'm more interested in is the trend, is what's happening in terms of my difference in use of these models last year versus this year, and then what do I expect that projection to look like next year. And if we've looked at sort of some of the problems which there's been rapid progress on, I would say it's coding and it's mathematical reasoning. And in many ways, the reason for rapid advances there is that we have great feedback signals. Sort of the best feedback signals we get are from closed systems, one in which it's clear if you've won or if you've lost. And certainly in math, many times it's clear that you have arrived at the right answer because verification is easier. But certainly in coding as well, if you're trying to solve something and you can verify that you've gotten to an output which makes sense, that means your coding task has been completed. And in cases where you have that loop, you're able to rapidly learn, we're able to make rapid progress. I'll just bring that to medicine for a second, which is that many times it's not actually possible to understand whether the action you're taking or the decision you're making, the prediction you're making, actually is correct. That's part of the challenge that makes it hard to think about that loop being closed. And so from a domain perspective, I think of medicine as challenging in at least a couple of different ways. One of those ways is that unlike many of these domains in which we can make rapid advances because we can verify the answer very quickly, in medicine, a lot of the verification step is still not scalable because we have to rely on people for it. And the way it might be done is if my AI model says something, I might go to Martin and I say, Martin, put your doctor hat on. It's like, what do you think is actually the truth here? And that's very slow. Regardless of how many people I have at my disposal, that is always going to be slower than having some sort of full automation in that pipeline. And what we've seen is that it is problems of that nature where in many ways we are stuck at human level capabilities rather than the ability to actually demonstrate superhuman capabilities. And so, that's sort of what I think about a lot is compared to where we are and where we're about to be, it's very clear that on closed loop systems, how we're going to make rapid progress. It's less clear on non-closed loop systems, how we're going to make rapid progress.
Yeah, that's interesting. And especially indeed the domain transition from, mathematics where it's just clear you have a certain answer. And in healthcare, it's just very unclear, like what is the actual answer? When we have this role separation between AI and the physician in the healthcare space that you're proposing, how would that in practice look like? Because a lot of people can imagine, okay, a radiologist is with their PAC system and they get some AI pop up like, oh, there's 10 nodules in this CT scan, please look at that. But if we're separating that, have you thought about how that would look like in practice?
Yeah. I think in many workflows, there are things that we would do if there were no time constraints that we don't do because there are time constraints. let me first start with the domain of research. Before embarking on any research journey where you're claiming to make some novel discovery, we want to do a literature review. A lot of that literature review is in the service of me or my student educating themselves on what's actually going on in the topic, what's been covered. But a lot of it is in the service of asking the question, has this been done before? And a lot of time can go into answering that question, maybe 2 weeks, 3 weeks. And so a lot of people are not able to take that to the fullest extent. You know, you might spend maybe a few days to try to see if there's anything in that area, really try to read, search the right papers. But the research workflow of today, and certainly of tomorrow, is very much trending to that you have your ChatGPT and you're writing into it, like, give me an analysis of this topic and whether this problem that I'm interested in has been solved. And, you know, I remember 5 or 6 months back, the results were absolutely garbage, in which a lot of the key papers, a lot of the key recent advances, these systems used to miss. They don't do that today. And so I see this as a concrete example of role separation. Is today a lot of activities relating to research, which involves searching something on the web and just going down this rabbit hole of paper to paper to get me to the right paper and then get me to the right paragraph, which has the right information. I can take that out of my role. I can take that out of the role of my PhD student. A lot of ways that I think we think about role separation today is things that I would do if I had infinite time that I simply don't because I have very limited time. So therefore, the delta between limited and infinite time is what I should have the AI do. And so let me come back to the world of medical imaging. Let's take potentially benign lesions. You know, a lot of people have renal lesions, some hepatic lesions, take pulmonary nodules. There's no time in clinical practice to be able to document certainly all of these, document the sizes of all of these, but you know, a small fraction of them will turn out to grow, have the potential to be malignant, and it would surely be appropriate in some of those settings to have done that measurement and that analysis. But in practice, you know, with the trade-off of the time it takes, people don't consider it necessary to do as part of practice. Great, let's have role separation come in there, which is let's have the AI be responsible for that, and let's have the humans do exactly what they would consider the task in limited time. And you know, you can take this a little bit further as well. I think one of the areas that you see a lot of interest in today, not just in the country but outside of the country, is wouldn't it be great if AI could read like a third of my chest x-rays or a third of my bone x-rays without me ever having to take a look? Because, oh, we don't have enough people to do that. We would like our people to do CT or MR interpretation. And in this case, the role separation is very much, let's have 30% of cases be that are confidently normal, according to an AI model, be reported by those AI models. And let's have the humans focus on the 70%, which is going to take time and which is going to have abnormalities. So these are the sort of things that we wrote about in the New York Times article earlier this year with Eric Topol. But certainly the way that AI systems are advancing, but also the need for these from a human need standpoint is going to drive us to thinking about role separation as the answer.
Yeah, that makes a lot of sense. Like there is a lot of work in the like daily work of doing measurements that physicians, and in this specific use case, radiologists hate to do. I have done a lot of work in the cardiovascular world and doing all these measurements of the aortic diameters that's not fun. If you can automate that piece and then just have the radiologist look at the general image indeed and make the interpretations. And then indeed also looking at normal exams makes a lot of sense as well to improve the workflow. So that makes sense. We actually got a question in the chat here from one of the attendees. The question is, where does the responsibility lie, both legally and ethically, when AI and clinician judgments diverge? So what if the AI makes a mistake in the measurement they do, or they say this is normal, but it's actually not normal?
Yeah, I think it's a good question, and I think it's very much a question of the risk-reward trade-off that we think of as acceptable. So let me turn to reasoning by analogy once again and look at the case of autonomous driving. So in autonomous driving, real-time decisions have to be made. And so in real-time decision making, you essentially have no human backstop, right? Your car is driving along the way. Any mistake it makes, it has to take ownership for, because there was no human. It could have said, oh no, I don't know what to do here. Human, take control, if you're sitting in a Waymo. Now, if you are in the case in which you have one of these cruise control systems, they do in fact ask the human to take over when they are faced with a scenario that they don't actually know how to confront. And so these already give us two different models of deployment of medical AI systems. One is a system in which there is no human backstop. And that means that whatever the AI says is final, and whatever the AI says is what's going to happen in terms of the patient's consequences. And in that scenario, there's certainly no human to take on the liability. So from an institutional standpoint, there are two parties that can take liability for that. Number one is the practice that chooses to deploy such a system, in which case the math is fairly straightforward, is that if it's giving them enough benefit and if it's accurate enough, then maybe they will be willing to take on that liability, because from a business case, the risk reward makes sense. And the second is the AI developer. And the AI developer might say that my risk reward is such that I don't believe that there will be many occasions in which there will be liability implications as a result of having the system be deployed autonomously. And so those are broadly, I think, the two ways that the fully autonomous setup would work. I think the way the majority of the setup works today is that we think of the humans as the backstop, who ultimately take on the liability if they are licensed to do that particular thing. So for example, in radiology, the systems of interpretation are assistive and are not meant to do more than say, you, the radiologist, have your final say. I'm just assisting. And the liability is on the individual radiologist to make sure that everything is as the AI actually points out. Now, where this gets complicated is where there's a disagreement, which is if the AI actually said something that was right, but the human overrode it to get to the wrong thing, what's going to happen then? And so these are the sort of things where I think we are entering, in some ways, an extension of what we already know about medical legal considerations in terms of how things already operate. But then in the autonomous land, very much so a new world in which how things can and to some degree should operate based on the cost and benefit to society.
There are more questions coming in, but I just want to make sure we cover the real-world performance of AI in radiology versus what we see in the lab. So what is your take about the real-world performance when an algorithm is deployed versus how it was, for instance, reported in the FDA submission?
I think there is a very easy solution to this, right? Which is, why don't we just test our AI out on every patient scan everywhere in the world? That would solve most of our problems. The unfortunate nature of the world is that we are not able to make that assessment. And I truly and strongly believe that if we were able to make that assessment, that everything that we would see, everything that we see about the way these models fail would be known in advance, certainly. And also, in many ways, we would have the ability to control for that kind of failure. And so the way I almost think about it is you have access to a very, very small pie, and you're not able to observe the variation of what goes on in the world. And so you better be sure that whatever you do test your model on gives you a full view of the way the world works. And so that was the sort of frustration that I think I had, when I started my faculty position in 2021, and this idea that we needed to have ways of making this data available to researchers was one of those things that I felt like certainly the community really deserved. And in many ways, it's an incentive alignment problem, which is, why should someone make their data available? And what is the sort of incentive to do so versus the risk involved in data sharing? And so certainly on that front, appreciative of the kind of work that Segmed's done in this area, and academic efforts have tried to make this happen. And so compared to certainly a few years ago, we have a lot more data than we did out in the world, and that's certainly led to people developing and evaluating models, and us scientists learning a lot more about the way these succeed, the way these fail. But I also think there's just a lot more work to do. And I don't think there's a substitute for just evaluating on larger data sets than we have been.
Yes, for sure. So we cannot test on every scan for sure. So that's a big part of our work, to make a reliable sample of real world data, so we can test the algorithms on. So that's a good part of what Segmed does, indeed. So we have a question in the chat. Let me read it, make it shorter because it's lengthy. So the attendee, unfortunately, we do not have the attendee's name here, but they describe a situation where it looks like the clinical context does not always match what the AI was trained for. So there is like a mismatch of what the AI was developed for and the actual clinical scenario. So they really like the idea of AI helping to filter out negative cases, but are less sure about relying on AI for positive cases. So do you see any challenges or risks with that? And how do we kind of balance the AI output for different scenarios? And I think in the spectrum from normal to abnormal cases.
Yeah, I mean, I think part of it is that one of the things that differentiates today a way a human expert operates from the way AI models operate is what happens when this scenario happens. So let's say a radiologist who's trained to interpret adult cases gets a pediatric case, says, nope, this needs to go to a pediatric radiologist. I'm done here. And but what does the AI model do? A lot of the time, the AI model is just going to come out with a prediction. And part of it, can be solved here by just looking at the age. If age is smaller than whatever, 22 or 18, reject. But you can easily see how this doesn't apply to every single situation. Where one, you might not have access to the age, in which case, what are you supposed to do? You might infer the age from the images of the data itself and say, okay, but you can quickly see how there is a very, very quick problem that comes up of I need to know where my expertise applies and where it doesn't. And we as people, certainly, you know, the humble ones are able to make that determination to say, this is outside of my expertise. So, you know, I shouldn't do this work, certainly not if I'm taking on the liability. But I think a lot of the ways that we have thought about the productionization of AI models has been to optimize for their application on as many scans as possible, or, you know, certainly be able to use rules when possible to say I should accept this and therefore give my answer. But there's almost no mechanism by default of saying I don't know on any particular input, and I think that's a cause of many of our issues today.
Yeah, it would be great if the AI could just say, hey, listen, this is just a case that I haven't seen before or I haven't been trained enough on. Let me skip this one. Yeah, that would be actually great in the future. And now that we're approaching the end of the webinar, let's look a little bit more into the future and the road ahead. Let's say we would invite you again in 3 or 5 years to another Bytes of Innovation webinar. What do you think would be a successful kind of like progress that AI could have made specifically in the medical imaging space?
For the last 5 years or so, I've had the goal of having AI be able to do every task that someone who's looking at medical images does. Sort of, if you think about it, a medical imaging intelligence layer. And it was late 2023 when it was beginning to become clear how one would go about building such a system, that I actually decided to co-found a company that's now called A to Z Radiology AI. And there, the idea has been that a lot of what we need to accomplish happens at scale and happens with determination to make progress towards that goal. And we've accomplished that to a very large degree in abdomen pelvis CTs, which is considered one of the most complex modalities, where our AI now internally, our prototype can do 365 findings on these kind of scans. And so I think, to me, every year we have got to make more and more progress towards saying that many more kinds of answers on many more kinds of medical images can now be done as part of a single system that's just able to get you the intelligence that you need. Unlike today, where if you wanted to say, you know, what I'd like to do is I'd like to find all lesions on this liver, and then go ahead and tell me whether this patient is likely to have a rupture of their aorta, you would probably be spending time finding or building models for each one of these. You're not going to be calling one model like ChatGPT to solve this. But this is obviously, I say obviously because I believe with strong conviction that this will happen, and that when that happens, that it would completely change the way we think about getting intelligent insights on medical images.
Yeah, that makes sense. So are you saying here we got to go from narrow models where we have, you know, like a one-trick pony, we can do one thing with this, towards models that can do 365 features and maybe even more in the future?
I think we're looking at a vision in which a single model can do tens of thousands of different things, all as part of one system. and without regard to the end user for whether that's tens of thousands of different models or one single end-to-end trained architecture that can do it all.
Yeah, that's awesome. And okay, cool. Then we have 2 more minutes. I'll one last question. So the innovation goes really quickly. We see almost every month or every week, we see a new AI model coming out, both in the healthcare space as well as, these large foundation models, OpenAI, whatnot. How can we make sure that this fast technological development that keeps track with the healthcare development? Because we have to be a little bit more cautious, right, when we're dealing with patients.
I think we all want to see things that are safe and effective be deployed. And in large part, I think outside of the space of medical imaging, when it comes to text-based tasks, we've seen this dramatic progression of things that actually work in practice. And of course, with lots of work going on, finding out the edge cases and where they do not work and where we shouldn't rely on them. But what's also true is that these have translated from prototypes to actually being deployed everywhere very, very quickly in healthcare. In that, if you look at the exposure today of physicians to AI within the US healthcare system, it's extremely high. And if it's not extremely high by absolute numbers, it's certainly extremely high by the velocity of deployment, both at an individual as well as an institutional level. And so I'm very bullish on things being deployed once they really, really work, because really, really work is very, very compelling from both a clinical value standpoint, from an operational value standpoint, from a financial standpoint. I think everything starts coming together if we can get the technology to really work. I think one of the things that stopped us from having that same pace is within medical imaging interpretation at the very least. We've had fewer moments of magic where it's so clear that life with a technology is so much better than life without the technology. And I think that time will come. There have been glimpses of that magic, but it's going to start to be so much more clear as the technology leaps further and further over the next few months, the next couple of years here.
Awesome. Well, Pranav, I would really like to thank you for joining us here at Bytes of Innovation. We learned a lot about the separation between AI and physicians. We learned about going from narrow AI models to broad AI models. So thanks a lot. I would also like to thank Aline, my co-moderator, for always being there at Bytes of Innovation and hosting these sessions. And of course, I'd like to thank the audience for attending. It was a great session. Next week, we will have another Bytes of Innovation. It will be on Wednesday, November 12th with Dr. Tim Stick. I hope to see you all then and have a nice rest of your day. Thanks, everybody.